Welcome back. We have a question here that reads, a uniform horizontal beam of length 1 meter weighs 90 newtons. It rests on two supports P and Q placed 20 centimeters and 10 centimeters from the ends of the beam respectively. Weight of mass 8 kilograms and 7.2 kilograms are placed near P and Q respectively, one on each end of the beam. Calculate the reactions at the supports P and Q. Solution. Let's first try to draw our horizontal beam, and this is the horizontal beam. This horizontal beam lies on two supports P and Q that are 20 centimeters and 10 centimeters from the ends of the beam. So let's try to indicate them. This is the first support P and this is the second support Q. If we should go back to the question, it says that the supports are placed 20 centimeters and 10 centimeters from the ends of the beam. So we have 20 centimeters from one end of the beam and 10 centimeters from the other end of the beam. The supports are P and Q respectively. So it says weight of mass 8 kilograms and 7.2 kilograms are placed near P and Q respectively, one on each end of the beam. So which means the weights that are given here are suspended at the ends of the beam. One of them is near P, the other one is near Q. So because it has used the word respectively here, it means that the mass 8 kilograms is the one that is near P and the mass 7.2 kilograms is the one that is near Q. So let's try to indicate that. This is where the mass 8 kilograms is going to be suspended. So which means if I should convert it to force or weight, that will be 80 newtons, okay, by multiplying it by 10. And for the 7.2 kilograms, it is suspended at the other end of the beam. So 7.2 kilograms, if you convert it to force or weight by multiplying it by 10, that will be 72 newtons. Okay, so since the beam is a uniform beam, it means that its weight has to be at the center of the beam. Okay, so the beam itself weighs 90 newtons. So we will indicate that at the center. That is 90 newtons. Now we want to know the reactions on the support. Okay, so let this be the reaction on support P, and let this be the reaction on support Q, RQ. We want to know the distances that we have here. Well, one thing that you have to know is if the force of 90 Newton is at the center of a 1 meter beam, it means that it lies exactly at the 50 centimeter mark, okay? Meaning from one end to the 90 Newton force is 50 centimeters, okay? Or 0.5 meters. So if from here to here is 20, it means that from here to the force will be 30 centimeters, okay? Such that 20 plus 30 will be 50 centimeters. That is exactly halfway, right? So it means that from here to here will be 40 centimeters, right? So that it can also be halfway from the right end of the beam, okay? So we have to indicate that. So from here to here will be 40 centimeters. I hope you understand. To give a quick recap, we have a horizontal beam that rests on two supports, P and Q. Support P is 20 centimeters from one end and support Q is 10 centimeters from one end, okay? The weight of the beam is 90 newtons, but since the question has mentioned that the beam is uniform, so which means the weight has to be exactly at the middle. So from one end to the middle, it has to be 50 centimeters because it is 1 meter. So what is half of a meter? Half of a meter is 0.5 meters or 50 centimeters. So that is why we have it located here. So if from here to the support P is 20 centimeters, so I will ask myself, how much do I need to add to the 20 centimeters to have 50 centimeters? That becomes 30 centimeters. The same thing from the right end of the beam to where you have the support is 10 centimeters. So how much do I need to add to 10 centimeters to come halfway is going to be 40 centimeters. Okay, so that is how we have the 40 centimeters here. We know that we have to use the length in meters, all right? So the centimeter is just to help you understand the concept there. So for the 20 centimeters, remember that has to be 0.2 meters. For the 30 centimeters, it has to be 0.3. For the 40 centimeters, it has to be 0.4. And for the 10 centimeters, it has to be 0.1. Now let's move ahead to solve the problem. We can identify our forces that are clockwise and anti-clockwise. Let's say we are taking moments from P. So which means the 90 newtons will be acting as a clockwise force. The 72 newtons force will also act clockwise. The 80 newtons will act anti-clockwise. RQ will act anti-clockwise. Okay? For RP, since we are taking moments at P exactly, the moment will be 0. So there is no need of considering it. Now, we will say for vertical equilibrium, we say that upward forces must be equal to downward forces. So what are the upward forces here? We have RP and RQ. So it means RP plus RQ is equal to the downward forces are 80 newtons plus 90 newtons plus 72 newtons. So RP plus RQ is equal to 242 newtons. Okay, so we can maintain this as equation 1. Now we will go for the horizontal equilibrium. For horizontal equilibrium, clockwise moments is equal to anti-clockwise moments. Okay, we are taking moments from support P. So we are now going to state the moments. So for the 90 newtons force, the distance is just 30 centimeters or 0.3 meters from P. Okay, this is just the perpendicular distance. So that is going to be 90 times 0.3. Then plus, what is the other clockwise moment force? For the 72 newtons, the distance from P is 30 centimeters plus 40 centimeters plus 10 centimeters. That is 80 centimeters. So 80 centimeters is 0.8. Okay, so it means the distance from support P to the 72 newtons force is 0.8 meters. So that is going to be 72 times 0.8 meters. So this is equal to the anti-clockwise force. We have RQ. The distance from P to RQ is 30 centimeters plus 40 centimeters, which is 70 centimeters. So 70 centimeters is 0.7 meters. So that is going to be RQ times 0.7. RQ times 0.7 meters, then plus. So for the other anti-clockwise moment, the 80 newtons force has a perpendicular distance of 20 centimeters, otherwise 0.2 meters. So that is going to be 80 times 0.2 meters. So we can now move on and do the calculation. 90 times 0.3 is 27 plus 72 times 0.8 is 57.6. This is equal to RQ times 0.7 is 0.7 RQ plus 80 times 0.2 is 16. So 27 plus 57.6 is 84.6. This is equal to 0.7 RQ plus 16. Collecting like terms, we will have 84.6 minus 16 is equal to 0.7 RQ. 84.6 minus 16 is 68.6. This is equal to 0.7 RQ. To find RQ, we divide both sides by 0.7. So RQ is equal to 68.6 divided by 0.7. RQ is equal to 98 newtons. So if RQ is 98 newtons, what is RP? We will go back to our equation 1, which says RP plus RQ is equal to 242 newtons. Using equation 1, RP plus RQ is equal to 242 newtons. So RP plus what is RQ is 98 newtons. This is equal to 242 newtons. So RP is equal to 242 newtons minus 98 newtons. RP is equal to 144 newtons. So therefore, the reactions at the supports are 98 newtons and 144 newtons. Thank you very much for watching this video. Please subscribe to the channel, like and share our videos.